Hello guys, today we will study about the principle of mathematical induction. Okay, what principle of mathematical induction? Okay, induction word is derived from induce. Induce means like suppose if there's a one slice or a slab or a tile here or a brick. So if you make like this, arrange like this, if you just push force, apply the force from here, then it will be just falling. Every induced effect of this will give a force to this, and induced effect of this and this simultaneously it will be induced. It is the form of induction. So every tile will be fallen, right? So this is the one just simple notation of principle of mathematical induction. Okay, so basically principle of mathematical induction is a subject in NCERT class 11 mathematics chapter 4, right? Yeah, so the principle of mathematical induction, there's a three step to use the principle of mathematical induction. Step one is we have to first check whether the given statement is check whether the given statement is true for n is equal to 1. Okay, first step is check whether the given statement is true for n is equal to 1. Okay, now for step 2 we use what step 2 is just assume that given assume that the given p of n is true for n is equal to k, where k is always positive, where k is positive integer. Okay, so positive integer. Assume that given p is true for n is equal to k, and the k is a positive integer. Now talking about the step 3. Step 3 is what we have to prove that we have to just prove that result is true for any positive integer. Okay, so this is the three main step uh, to use the principle of mathematical induction. Okay, positive integer k, prove that result is true for p of k plus 1. Okay, for any for any for any positive integer k. So these three steps are mainly used in mathematical induction. So we will proceed these steps in the example later. Okay, now before just going on the example, first of all we will try to just use our common sense to solve the problem. Okay, so 1 plus, suppose the equation is 1 plus 2 plus 3 plus so on to n. Okay, and this total sum will be n into n plus 1 by 2, right? So which we know that, right? Because the summation of c. How this formula was derived, so use your own imagination to solve this. Okay, see, 1 plus 2, if I multiply this 1 into 2 and divide by 2, what I will get, of course 1, right? In the same way, if I do this 2 into 3 divided by 2, of course we will get 2, right? If I do the 3 into 4 by 2, of course we will get 3, right? So the back step will be always getting like this, right? So which we can use the formula as what? 1 into 2. Of course we can say that 1 plus 2 is 1 is 1, right? So 1 plus 2 is 3, and 2 plus 3 is, of course we can say it's 4, right? So let me write this. Wait, let me reduce first. 1 plus 2 plus 3 plus so on to n is equal to n into n plus 1 divided by 2, right? So 1 is the sum of these two numbers is 3, right? Sum of these three numbers is 3 plus 2 plus 1 is nothing but 6, right? In the same way this will be 10 and so on, right? So we get 1, 3, 6, 10 as a sum, right? So last term will be what? Of course 1 is what? See, 1 is 1 itself, right? That is 1. 1 can be also formed through by multiplying this 1 into 2 by 2, right? And 3 can be 2 into 3 by 2, because 6 by 2 is 3. 6 by 2 is how much? 2 3 is 6, 6 by 2 is 3, right? 2 1 is 2, 1, right? Because now we get this summation, right? 1, 3, and 3 into 4 is 4 3 is 12, 12 by 2 is 6. So we get, of course, the formula like n into n plus 1 by 2, right? So the last will be n into n plus 1 by 2, which is genuinely studied through the mathematical form numbers, right? So we get this 1 3 6 9 as a sum. Okay, in the same way, if we do for the 1 square plus 2 square plus 3 square plus so on to n square, which is also equal to the n into n plus 1, 2n plus 1. So we will prove this, okay, using this above notation. Okay, so see, the 1 square is 1, right? So 2 square is 4, 4 plus 1 is 5, right? So 9 plus 4 plus 1 is how much? 9 plus 1 is 10, 10 plus 4 is 14, right? So 14, so of course this is 13, 30, and so on, right? So we have to use this as a reference to solve this, to get this value. Okay, so 1 is 1, same, right? Let it be. And 5 here is 3, right? So how can we make 5? We can say that 3 times 5 by 3, isn't it? Because 3 3 cancel, we get 5, right? But we have the value 3, right? So 1, so let me write it here, a 3 by 3, okay, so that it will cancel, this will become 1, right? So there's a 1, see, it's very important. So see, 1 3, now we get this informal line, right? So obviously there will be a 6, right? And denominator is all same, right? 3 3 3, so I write here 3. Okay, so 3 1 is 3, 3 2 is 6, right? Here we have a 2, right? So which means here we have a 17, right? Here we have 5, so we get 5, right? 3 3 cancel, 5, right? So here 3 1 is 3, 3 2 is 6, right? So 2 multiplied by how much we will get 14 is 7, right? Are you getting my point? 7, 3 1 is 3, 3 2 is 6, right? 2 multiplied by 7 is 14, right? So we get 14, right? So the next term 30 will be, see now 1, 3, 6, it's 10, right? So 10 is here, right? A denominator will have always 3, right? Because the formula we are making is 3 3 3, right? So of course this will be 3 1s are 3, 3 is a 9, right? 3 1s are 3, 3 is 9, 3 into 10 is 30, right? So we get 30, right? So the last term will be what? 1, 3, 6, 10 is what? Of course n into n plus 1 by 2, right? So the last term will be summation. This is the summation, okay? This value is the summation. So we get the value C. Summation is n into n plus 1 by 2, right? Multiply by 3. So 1 3 done, right? Now we're talking about the 3 5 7 9, right? So this is what? Odd number, right? So odd number is represented by what? 2n plus 1, okay? Odd number is represented by 2n plus 1, okay? Okay, now denominator all have 3, right? So 3 is common. So of course if we multiply by 2 into 3, we will get 6, right? Hence it is proof that we can write the formula n into n plus 1 by 2n plus 6, right? I getting my point. So this is true, right? Now we will talk about the using this formula will be derived using principle of mathematical induction, okay? See, so we will talk about the principle of mathematical induction. So first of all, we prove that 1 plus 2 plus 3 plus so on to what n is equal to n into n plus 1 by 2. We have to prove, right? So first step state that it is true for n is equal to 1, right? So if I put 1 here, so it's 1, right? So right hand side will be 1 into 1 plus 1 by 2, which is nothing but 1, right? So P of 1 is true, right? So now we have to study about the P of k. We assume that the P of k is true, okay? Which means 1 plus 2 plus 3 plus so on to n is k, and this is k. Instead of n, I put a value k, okay? This is true, okay? Now we have to prove that p of k plus 1 is also true, right? So 1 plus 2 plus 3 plus so on to k, and next term will be what? It is k plus 1, right? So I write here k plus 1, and of course n is k plus 1, right? So I put here k plus 1. If I put here n k plus 1, n has a k plus 1, this will be k plus 1 plus 1, which is nothing but k plus 2, right? Divided by 2, right? So 1 plus 2 plus 3 plus till k is what? Value is this, right? This is the k into k plus 1. If I can put here the value 1, 2. Still from 1 to k, we can put here this one value k into k plus 1 by 2, okay? So plus k plus 1. So we have to prove this equation right hand side, right? So of course this will be, if I solve this, what we get will be LCM k square plus 3, 2k plus k is 3k, right? So it's 2. So if I just middle term factorize, I will get what? K into k plus 1 by, so of course it will get k plus 1, k plus 2 by 2, which is proof, right? Left hand side and right hand side proofs. So p of k plus 1 is true. So step 1, step 2, step 3 done, right? So these all are true, which means the mathematical induction, the formula is true, okay? N into n plus 1 by 2, okay? In the same way, we can do for the 1 square plus 2 square plus 3 square plus so on to n square, okay? It will give what? It will give uh, n into n plus 1, 2n plus 1 by 1 divided by 6. We studied before, right? So yeah, this will be, of course, equal to, of course, we can solve this as a p of 1 is 2. So if I put here 1, this becomes 1 plus 1, 2. And this will be obviously equal to 3. 6 by 6 is 1, right? So we just left hand side 1 is true, right? This is 1, true. So this is p of 1 is true. Now talking about the p of k, if I put here instead of n, k, we have to use the value, instead of n we have to k. So 1 square, 2 square plus 3 square so on to k square, right? Is equal to how much? K into k plus 1, 2k plus 1 by 6, right? So we get this p of, now talking about the p of k plus 1, it will be 1 square plus 2 square plus 3 square so on to k square. After that we will get this, we have to find the p of k plus 1, okay? So this is k plus 1 whole square, which is equal to, this will be obviously equal to k plus 1. If I put here k plus 1, this will be k plus 2, and this will be, if I put here k plus 1, this will be 2 2k plus 3, right? Because if I k plus 1, 2k plus 2, 2 plus 1 is 3, right? So there are 6. So from left hand side, same we have to use this. Instead of this, I can put here this. This will be k into k times k plus 1, 2k plus 1 by 6 plus k plus 1 whole square. So from here, I can take k plus 1 common. The remaining left is what? So I multiply this k into 2k. Okay, this will become what? 2k square plus k plus, okay. So from, I have to use the LCM, okay, otherwise I can take common. So this will be plus 6, okay. LCM I have to do. So of course this will be 2k square plus 6k plus 1 is what? 7k plus 6, right? By 6, right? So I'm doing left hand side, okay. So yeah, now we can k plus 1. Here we have k plus 1, right? Now we can solve this as 12. 12 into 4 into 3 is 12. So we can use the middle term factorization, 4k plus 3k plus 6 by 6, right? So on solving this, we get what? If I take k plus 1 common, from here I can take 2k common, which means 2k, and from here we can take 3 common, which means 2k plus 3 is common, and 2k, if I take 2k common, what will left? K plus 2, right? Here also if I take 3 common, we will left k plus 2. Hence the equation is left hand side, right hand side, and left hand side is proof, right? Both are same, okay? Which means we just proof. So the principal mathematical induction is all about this, right? So you have to prove the equation, hence it's proof, right? So that's all. Thank you.